So, how do we start this?
Hi, my name's Josh. I'm the Pipeline Timeline Specialist at Foundry. I've been working at Foundry for about 2 years now, and I come from a background of 20 years worth of working in studios as a pipeline TD and also head of pipeline. I understand all of the troubles that kind of go into making sure a studio can integrate with the software and build good workflows that artists can actually use.
Hi, I'm Frank from Ohu FX in Wellington, New Zealand. I've been using Hiero in particular for about 13 years, and it sort of became the backbone for everything I've been doing from TVCs through short films, and in the last few years I've been running full feature films through the software with a particular workflow that ultimately got me really excited because I realized I was able to run entire feature films from start to finish as a client-side supervisor by myself, holding things together that usually require many more departments, and that prompted me in trying to share some of those concepts and workflows, and that's what we're hoping to show you in this video. So what you're about to watch contains the bullet points of start to finish, really. We start with ingest. Quite often you get a whole bunch of data, you don't even know what it is, and you have to prepare it for the team. That's what I've been using Hiero for the longest time. But it also will go into building swap cuts that will enable the entire team to review their work in context of the cut. It will go straight into a dailies workflow, which utilizes code that Josh has been writing and that I'm very excited about, and that naturally just flows into the delivery potential of Hiero.
Yeah, I'm really excited to go through some of the API elements and kind of get into, the swap cut stuff's amazing. I think people are going to take a lot from this. I hope you enjoy the video. Welcome to the Hiero Masterclass. Let's go over the class goals. We want to use Hiero to provide an end-to-end workflow that details key tasks when ingesting, reviewing, and delivering content. We want to provide a breakdown of each of the below processes using real-world examples. The first section, ingest, we'll go through importing the media, validating and fixing any media naming issues using tags and Python snippets, go over OCIO configuration using look tracks and Python snippets, and we're going to export to the file system or shotgrid/flow. Then we'll move on to review. We're going to build a swap cut. This is to facilitate contextual review. We're also going to look at a bonus tool called Cut Detector. We're going to assemble a sequence with pointers to potentially non-existing media, such as previs and lighting, so that your artists can review in context. We're going to demonstrate a dynamic review process. We're going to import content from ShotGrid using Nuke Timeline Loader. I'll cover what is Nuke Timeline Loader. We'll load a dailies playlist into a sequence, provide review notes, create some annotations, and publish them back to shotgrid/flow. And then finally, the delivery portion. We'll follow on from the NTL imported sequence, build some tracks for a QC workflow, and then export the delivery for the client.
Okay, so let's dive into the turnover that we were given for this film. In this case, it's called CDL TO1 for turnover 1 with a timestamp, which is quite common for editorial to turn over like this. And inside we have a bunch of subfolders, God knows what's in it at this point, and an EDL in OCIO file format. So when I say EDL, I usually refer to the concept of an edit decision list, not to the rather old file format .edl. In my mind, just about all edit decision lists should be transferred and exchanged with OCIO file format these days. So I typically do not start by dragging the EDL in and conforming it to disk, because there could be a whole bunch of stuff in those subfolders that is not part of the edit decision list, but still might be needed in our ingest. So what I usually do is I pop up one level, drag the folder that has a meaningful name for the turnover into Hiero, because Hiero mirrors the file structure on disk. So we can now browse the bin just like we would the file browser, and that makes it a lot easier to correlate things with the file system itself. So let's go through and have a look. So the first bin, called CCTV, seems to have a whole bunch of CCTV footage. This guy is black, so let's double click and investigate what's going on. So it's just the first couple of frames that were black. And since this crew member here is in frame anyway, that's probably throwaway for the handles. So that's probably okay to ingest as is. So in this case, I would set the poster frame to middle so it doesn't look like a broken clip in the bin. Next, we have a GFX folder. And in here, we have all the monitor inserts we needed to put onto all those monitors on set. We labeled them A1 through B3 to be able to allocate the correct graphics to the right monitor in the story to make sure continuity works. In the comms folder, there's a bunch of screen graphics for the comms app that is being used in the film. So that's just for comp to use as they need. And then there's a news banner folder that has a environment render and some news banners that are supposed to go on top. So if I throw that on here, we'll get a quick real-time preview of what that's going to look like in comp. So that's all good. So let's turn that wipe off. And next we have the offline folder. The offline folder contains all the proxies from the plates. So those will be center cropped and they have the color baked in. The baked in color is important because that helps us verify our OCIO color config, which we'll get to later. And then lastly, the actual plates folder containing all the stuff that was shot on set. You can see that we shot in a slightly weird wide format. So comp will have to use a center crop to satisfy the delivery specs. And in this run through, we'll also apply that center crop to the plates during ingest to give ourselves a QC plate. So something we can use as a difference key later on. In reality, we'd probably ingest both the unmodified plate as well as a center crop one for version zeros and for QCing. So at this point, I usually go back to the folder and grab that EDL. And this EDL is not the creative decision list, edit decision list for the film. It's just a string out or turnover EDL, which means it simply stacks all the elements that belong to the same shot vertically. And sometimes those are numbered nicely, sometimes they're not. So this really depends on your client-side editorial, how much work they've already put into enabling you to ingest this turnover nicely. So good comms to the client-side editorial is something I highly recommend. So our challenge here now is to obviously bring all this online, which is easy enough because we have already imported all those clips. So we'll just drag that onto the Match Media button. And that's a lot faster than matching the media against the file system again, because we don't have to traverse it. So now that we've got the whole timeline online, the task is to tidy this up and prepare it as much as possible for a export process that ingests all of this into our pipeline, ideally in one go. So I would start at the bottom to kind of get my head around how this is organized. At the bottom, we have two plates tracks. I'm planning to use the track names as subfolder names upon export later on. So I want those to be unique. So in this case, I'm just going to call that PL01 and PL02. This, of course, completely depends on your pipeline requirements. So that tidies up the track names. And what we want to do now is rename all these track items to make sure that shot name is the same shot code that we use in Shotgun. So everything can correlate via the shot name, which also empowers us to use or to maximize the templated workflow that Hiero comes with. And what that means, we'll see in a minute as well. I often use the spreadsheet to help myself select stuff in the timeline, as I find that a little bit more efficient. So in this case, if I would just want to select everything that's on PL01 and PL02, I'm just going to punch that in here as a filter. And now I can select all in the spreadsheet and only the stuff on those two tracks is being selected. I also like color coding things as I go, just as a visual help. So let's do that. And then, as we just saw, the shot names all seem fairly tidy. All we want to do is remove that CDL prefix. So that's something that the default renamer can do easily. Set it to find and replace, find CDL underscore, and just replace it with nothing. And that cleans up our plates. So we'll just work ourselves bottom up. If I now grab all of those. So I could select all of these guys, or again, if I wanted to use the spreadsheet for it, using the track names A1, A2, etc. is probably going to be too ambiguous. You can see how if I filter for A1, I'm already getting a whole bunch of plates. So in this case, if you wanted to really make sure you synchronize your spreadsheet view with whatever you want to operate on, I would probably use tagging and just tag those tracks with a tag that is easy to see, maybe the white one. And then in the tags bin itself, I'll find the same tag and use it as a filter. So now again, I can just select all in the spreadsheet and get the respective selection synchronized to the timeline. So once again, let's just color code this and have a look at all those shot names involved. So those are now pretty messy. Some of those, like S4 screen, they don't even have the entire shot name in their name. Others have all sorts of suffixes that we want to get rid of. So this is going to be a little bit cumbersome to tidy up. Even with the default renamer, this shouldn't be too hard. But usually at this point, I use a little bit of Python to help myself here. So let's have a quick look at some very basic Python API calls. So even if you're somebody who doesn't really want to deal with Python or coding or anything, I highly encourage you to learn at least some basics, because the ability to fall back onto Python really makes Hiero a bit of a Swiss Army knife for editorial, not just in the VFX world. So what we're doing here is we're grabbing the current or the timeline editor for the currently active sequence, which is obviously the one we're looking at. And then we're looping over the current active selection. So let's run that as a test. And that just simply prints out the current name of every track item that's selected. What we do then is we grab every track item's source clip, which provides us with a media source. And the media source provides us with the full path on disk for each selected track item. Then we just do the usual splitting by underscore and grabbing the first two items of the parent folder. So this is here, parent folder name, split by underscore, and then grab the first two items. If you look at the spreadsheet over here, that will leave us with S04010 in this case. So let's just run all of this. And that tidies up our shot names nicely. Except they're all lowercase s. So once again, let's just bring up the default renamer. And this time we'll use the change case feature to make sure everything's uppercase, which is what this particular project requires. So we'll just keep working ourselves up the track items. So I'll just switch over to something that I prepared earlier. So here I have tidied up the comms and the news banner track, tidied up the names and color-coded it, and I've also thrown the offline clips underneath the plates so we can get ready for checking color. But before we do that, I noticed that we still haven't included the CCTV footage. So that's those guys. And if we look at the clip names, they don't really tell us anything about the shots they belong to. So it's going to be a bit tricky placing them in the right spots in the timeline. However, there's a little bit of a hidden feature with the add column right-click option. And if you bring that up and type path, you'll see that there's a valid metadata key called path. And if we choose to add that, we can make the full file path on disk visible in the bin, just like we can see it in the spreadsheet as well. So the path now tells us where these items should be allocated. So I'll just find S690 for the first one. And again, I often use the spreadsheet now to jump around the timeline by name. Now that the shot names are all tidy, I can just filter that, alt-click on anything in the spreadsheet, and the playhead will jump to it and select that respective item. So we can very quickly jump around the timeline using the spreadsheet as a navigational tool. So in this case, I'm just going to drop that new CCTV element on top, so it lives on top of all the other stuff for this shot, and then pretty much do that for the other ones as well. So that brings us to this setup, and you can see I found that Shot 860 had multiple CCTV elements. So just like we did with the plates 1 and plates 2, or PL1 and PL2 tracks, I made 3 different tracks to make sure that we end up with unique naming for our export later. So at this point, I would look at our offline clip and our plates and get stuck into checking that our color workflow works well. First, though, you can see that the plate and the offline have completely different aspects, which makes it a little bit tricky to compare. So I'm going to give our sequence resolution the actual resolution of our delivery. So that flips that in. We make sure that all the offline clips are scaled to that sequence resolution. So I'll select them all, jump over to properties, and make sure they scale themselves to the sequence. And then we'll do the same thing for PLO1 and PLO2 again. Select them all. And this time we want to resize them in a way that fits the height and then just lose all the wings. And that makes the offline and the crazy format of the plates line up. So now we have an easier time comparing them. So the next step would be to make sure that our OCIO config is sitting well. In order to do that, I usually throw a new track on top, call it look, and put a OCIO color space node on top. And if we just look at the first frame for a minute, we pretty much see what we're after here. And our OCIO config is already loaded. So if we look at the additional color spaces that gave us, we can see 3 different types. They're all the client look per shot. And this one outputs back to linear light, which is something I like doing. So I can keep the timeline in linear light no matter what. And then one viewer lookup can control everything. You will have noticed that even though I chose our look linear, CDL and LUT combo, nothing has changed in the viewer, and that is actually a bit of a feature. And to explain that, I'm going to have to look into OCIO just a little bit. So let me bring up our OCIO config, which lives in CDL config OCIO. There it is. So if we just scroll down a little bit, you see those 3 color spaces that you just saw in Hiero, the look rec 709, sRGB, and linear, and they're all pretty much the same. They take linear input, turn it into Sony Log 3, apply a grade CDL, followed by a cube. Both of those have a hard-coded name, so they're not shot specific. And for the sRGB and the linear light one, I just apply the respective color space conversion to get the expected output. So you'll see that we are using context variables in our OCIO config, one for shot and one for sequence. But the only place we're using them is actually the search path. So if we look at the file system to see where we're getting our info from, the first entry in the search path is the LUT folder. So this is where all of our LUTs live, default LUTs that the client sent us. And if we go back up, the second one goes into a subfolder called looks, followed by the sequence and then by the shot name. So it's the classic sequence shot sort of tree. So if we hop into looks, we see we have the sequence level, then shot, and if we go into the shot level, we have the grade CDL and the cube file that we already saw in the declaration for the color spaces in the config. If you look at the search path again, though, there is a next entry that is only going to looks and sequence, and then the last entry only goes to looks. That means if OCIO can't find the CDL or cube on shot level, it will try it again on sequence level, and if it can't find it up here, it'll go onto show level looks and use those CDL and cube files. And the sequence level and show levels CDL and cubes are identity. So that means they're not changing anything. For debugging, you could set the grades to bright red or green, for example. But in this case, they're actually identity LUTs or grades as well. So, and that's why we don't see anything here. Cut a long story short, in order to see what we are expecting to see, we need to assign the correct context variables so the OCIO knows which shot look to apply. So I'll grab the Ohu sequence variable, and we're currently looking at SO120, so the value for the sequence would be SO1, and the value for the shot would be SO120. And the moment I hit enter, you see that the color is now being loaded properly. The plate and the offline are not quite in sync, so we could fix that just by nudging that real quick. And there you go. So now they are, and now we can verify that our look is correct. Of course, we're hard-coded to a single shot now, so once we travel across to the next shot, it's not going to get the right look. So we need to make this a dynamic lookup, and in order to do that, I usually use the streaming metadata that comes from the timeline. And to verify what's going on there, I usually use the text node. So just throw that text node up there as a little debug tool, and let me just roll that up and hit W to kill the wipe. Otherwise, the W hotkey lands inside the text. And just like in Nuke, you can use square brackets to invoke the TCL parser or the TCL expression parser. And the keyword in TCL to grab the metadata is simply metadata. So if we type that in square brackets, all the metadata that's currently available under the playhead will be rendered to the viewer. And you can see all the EXR metadata, but at the bottom of this block, you will also see the live metadata streaming from the timeline. And the key we're interested in is Hiero shot, because that gives us the track item name, aka the shot name. So let's change this expression to say we want the metadata Hiero/shot. That makes the text bounding box land up here. So I'm just going to reset real quick. 0, 0, width, height. So you don't have to look up the numbers. And now we can check if this expression actually does what we expect. As we scrub across different shots, we always see the currently active shot under the timeline. So that means we can now grab this expression and use it in our context variable for OCIO. Now we just do the same thing with the sequence. So we'll just figure out the expression that it takes to extract the sequence from this shot, and that's in TCL very similar to Python, split, and we want to split by underscore. And that leaves us with a space-separated list, which is how TCL works, and from there we just want the first index. So we go list index, L index, space, and then at the end we say we want the first index by specifying index 0. So you can use the Python parser in here as well, but I find that for those sort of one-liners, TCL is a lot handier. So let's take that and throw that into the sequence value and have a quick squiz if that's actually doing what we're expecting. So as we scrub through now, the shot name changes in the upper left as expected, and we always get the correct color. If we split it back to the wipe to make sure it all sits as expected. So this is how I kind of like setting up my OCIOs, because it means everything stays in linear light. I can always toggle the look on and off. And depending on how your workflow is, you can also use those color spaces to reverse them on the offline look to bring them back into neutral space. But that depends on whether your LUTs are reversible. Obviously, you don't want to be doing this at every time you set up a show. So what I did is I added a custom soft effect entry called apply linear look, which is a bit of Python code that follows an example that ships with Hiero, and that pretty much does everything we just did manually. So it creates a look track, throws another, throws a new color space node down, sets it to the linear color space, and applies the context variables as we just saw. And once that's sort of set up in your Hiero config, you don't ever have to do this again. Okay, so now we're pretty much ready to look at the export system, because somehow we need to get this stuff into our pipeline. With one of the track items selected, I'll just open the export manager to see how we're going here. I usually have all my master templates on the left, which means they're just XML files in my plugin path. My habit is to grab the ones that I need. In this case, I want to grab the plate ingest one, and I drag them over into the project, which means they're living inside the Hiero project file now, which means they're portable, and it's a lot easier to share a project among other colleagues, because they can see what templates have been used in this particular project. So likelihood is with subsequent turnovers, we will be using the same templates. So looking through the shot tree, let's just have a look how that works. So that you can see the preview for the currently selected track items. So the shots is a hard-coded subfolder name that we see here, followed by the usual splitting that we just did in TCL. So this is now done on templating level to construct the file path we're after, followed by a subfolder called plates and element type that doesn't do anything right now. The track name comes from here, because that's where the selected track item lives. And then we just construct the final folder and the final file name. So I wanted to give myself a little bit more control over this. So I added this element type token as a custom resolver. And if you look up the tooltip and find element type, you can see it tells you the element type token returns the value for the key called element type in a tag whose name starts with export info. Why would I want that? So I figured with all these, let's just save our work in the export manager. With all our work getting all the screen inserts on different tracks and the CCTV stuff, I would actually like to have all the GFX, monitor inserts, news banner, and comms exported to a specific subdirectory, and all the CCTV stuff I also want in its own subdirectory, so the plates folder stays a bit cleaner. And that's why I added this custom resolver. So let's have a look how that works. If I go to my projects tag bin and create a new tag and pretty much do what that tooltip said. So we will call this export info, or at least make sure the name starts with export info. And this one's going to be used for the GFX elements. So I'll call it _GFX. Double click it to add or preload it with some custom metadata. Just like the tooltip said, we want to add a key called element type. And the value is whatever we want our subfolder name to be as resolved in the export structure. So I'm just going to call this GFX. And just because we can, we will add a icon. Hit OK. And kill the filter that's still active from earlier. And in this case, since we're already zoomed out, it's easy enough to just select all of those. Oops, actually, also want to select these guys. And all of these track items should receive that particular track. And we'll do the same thing for the CCTV elements, except they should go into a different subfolder. So we will duplicate this tag, double click that again, change its name to something sensible like CCTV. And of course, the value for our subfolder should also be something sensible like that. Change the icon for sanity, so it's easier to figure out in the timeline what's what, and assign it. Okay, let's have a look at the results. So if I select one of those GFX elements and pop open the export manager, we can see that now the element type token resolves to an extra level called GFX, and one of those CCTV guys will use a subfolder called CCTV for the element type, followed by the usual track, etc. So now we have set up our structure The last thing we need to deal with is the actual cropping of the plates. As much as we set up our sequence earlier and reformatted our plates and offline references, that was just to actually be able to compare them in the viewer. I'm not applying any of this sequence resolution in the export manager itself. If we go to our processor here, you can see that the reformat is set to not reformat. It's not using the sequence resolution. That's because I really only want to reformat the plates to apply that center crop, and all the other elements should retain their original resolution. So the way I will be doing this is simply using a crop node. And if you scroll down in the processor, you see there's this additional nodes section. So we're going to utilize that. In order to figure out what it is that we need to be doing exactly, so I'm just going to copy a plate and its respective offline clip over into Nuke and paste. So this is our offline clip and this is our plate. And here is the crop that we need to match our offline. So I can select that crop node, copy it to the clipboard, pop back to Hiero, open our export manager, and now it becomes a little bit clearer what this additional nodes section is all about at the bottom. Just activate that, say edit, add an entry, and paste our crop node into the script section. So this now applies the crop node to every track item that's being processed. But as I said, I don't want to apply to every processed track item, but only to plates. So we'll assign one more tag to only the plates to make sure we can control the extra node a little bit better. So close out of here, make sure we save what we've done. And just like before, we'll just go PLO1 and PLO2 to use the spreadsheet to select all of our tracks. And then just grab whatever tag works, tag those track items, and open the export manager, find our processor and the additional node setup, and limit it to that particular tag that's now signifying which track items should be receiving this crop and which ones should not. If you're wondering why we're only seeing this one tag and not all of the tags used in the timeline, that's because there is a track item selected and I launched the export manager from the timeline. So that means it's preempting that you're only going to be exporting the selected stuff. You can launch the export manager from sequence level in the bin, or what I usually do, because I'm too lazy to do this all the time, I just select everything in the timeline and pop it open from there. And with everything selected, you see all tags in the respective fields. And in the additional node setup, you can see that we're now explicitly not using any of those other tags, but only the one that marks our plate. So with this, we're pretty much ready to export. So let's just run the first shot as a test. And to test, I'm going to have a look at the file system first. So all of these are going to land according to our export template in here. You can see there's a PLO1 subfolder. I'll just delete this to make sure we're looking at the right stuff, and select and export. So this is now creating the subdirectory required or dictated by our template. And here are all of our EXRs. And you will also see that in that EXR folder is a Nuke script, which is actually what's been generated from Hiero, because at this point, Hiero and Nuke share the I/O engine. And when you export something from Hiero, what you're really doing is you're creating a Nuke script that then gets command line rendered, which means you can keep it for debugging or for rerunning later on. Let's just have a quick look. Here's what Hiero generated, including our custom node that we added for the crop. So that makes Nuke and Hiero not just compatible, they're literally the same when it comes to I/O. The other thing that's happened during export is that the track item received a transcode tag, and that is significant because that enables us to very quickly bring all the exported clips back into the timeline for QCing. So if I pop over here to the state of the timeline that it is after export, you can see that every one of those track items has received that sort of export tag. And that means I can now use the track building system in Hiero very quickly to bring them back in to make sure that everything has been exported the way we expected it to. So if we say build track from export tag, I will call the receiving track plate ingest, which will also be the name for the new bin that will hold those new clips. Hit build, and you'll see that Hiero now builds the new track for you. That's a super time-saving feature. And then depending on your pipeline, the actual act of transcoding might have already published it for you. But at Ohu FX, it's a two-step process. So I usually do what I just showed you, make sure it's all sitting and is exported as I expected it to. And then I do another export step on those with a custom exporter that I put into the menu here that's called transcode and publish MOF. This is actually all default, so I didn't code any of this, I just inherited it. So I actually have a default plate publish template here. So that's what I usually use. It doesn't use the project root, it uses the incoming file path, creates a subdirectory called MOF wherever the EXRs live, and then constructs a QuickTime based on the source EXR sequence. And then I just added those two widgets up top. The rest is default. The file type in this case would be MOF, whatever offline proxy resolution and format you want to do. And then there's just a little bit of Python code at the end of this exporter that effectively lets Hiero do its default thing. And when it's finished, it grabs it and creates a new version in ShotGrid with any additional information from custom widgets. So once all the plates are ingested into a pipeline and artists are busy working, I usually start getting busy to build a swap cut, meaning a version of the edit of the sequence, or in this case, short film that we're working on, that enables us to cut in all of our work in progress as we go, and also something that enables artists to work in context of the cut. So let's have a look at the offline we were given by editorial. This now is actually the film, the creative cut of the film, so that we're no longer looking at string outs for turnovers. And we were also given a EDL. And in order to start my swap cut, I usually just drag the QuickTime onto the Set Reference Media button, so it parks itself underneath. In order to check whether those cut points are actually lining up properly, I tend to just copy the video track, offset it by 1 frame, call this additional track now previous frame. And now if we look at the top track in one buffer and the bottom track in the other buffer, switch to whatever view mode works best, and then jump from one cut to the next, we can very quickly see whether or not those cut points are correct, meaning the left and right side in the viewer should be different shots. And that all looks fine. So I can delete this again. And if you weren't given an EDL and you have to cut up this QuickTime manually, that's something that's happened to me one too many times. So I started writing a little PySide app called Cut Detector, which uses an open source library called PySceneDetect, which analyzes a clip and tries to find all those differences that signify a cut. This actually just loaded a CSV file, which is why it was instantaneous. That particular clip, 14.5 minutes at HD resolution, took about 60 seconds to analyze, so not terrible. You can tweak the threshold to try to capture as many legit cuts as possible, which will build the little shot table on the right, so you can cycle through that. And again, just like we just did in Hiero, you can verify if the detected cuts are actually proper cuts. You can also go over to the Find Missing Cuts tab, and if there's any cut that wasn't detected because the threshold was too high, you can find it in here. See if there is anything. No, that's all legit. But if there was a cut in here that wasn't detected, you can select that, hit C, and just start adding manual edits. And once that's done, you can select the area of the burn-in that holds the shot name, run an OCR across, And once that's done, you can apply everything to create a new sequence in Hiero that is cut up and uses the right shot names. So once that little app's done, it'll be available on Nukepedia for free. For those who don't know, we have been rebuilding Nukepedia from scratch. So it's actually a completely new database, fast and reliable again. So that's where you will find this tool eventually. But back to the demo. So if you aren't using the cut detector, what I would do is copy the cuts from this offline track onto my QuickTime. So we go to editorial and copy cuts. We want to copy all the cuts. We do want to copy the names because that enables us to use the templating system. We don't care about soft effects now. We don't care about tags. There aren't any. And we want to copy the cuts from the final offline track onto the reference video. We don't care about audio right now. And I also usually keep track of the edit name. In case we get edit updates, we can always refer back to that particular name. So at this point, you can get rid of this guy. And because we have sensible shot names, we can use the spreadsheet to find our VFX shots and select them in here, which makes it a lot easier to do than scrolling through the timeline. Once we have them all selected, I usually lift them onto their own track and call that shot ref. And at this point, I usually restore the bottom bit as well. So if I just select that remaining clip, which is still linked to its audio components, and you could manually drag out the out point, but I somehow feel better doing this in the spreadsheet by just copying the out point from the audio onto the video, and that stretches it out back to where it came from. So at this point, I can export shot-specific reference clips for the artists with handles, which means the handles will actually have the neighboring shot frames, which can be very useful. And I would also export audio files only for playblasting, flipbooking, and Nuke, etc. And once that is exported, I would continue building a track for plates. So since we don't have any tags like we did before, we can fall back onto the template system again and use a template that describes where on disk our plates live, just like we did before for QCing after we ingested everything. And once we have our plates in there, which we know are the foundation for everything that is coming through the pipeline, this is where I would go through and make sure that the timings and everything are sitting perfectly right. So I would probably go back to wipe mode, and with the plates track loaded into one buffer and the reference loaded into the other, now's the time to kind of be diligent and make sure that everything is frame accurate. So for example, in this case, you see that this shot needs a little bit of a frame offset. Now it lines up. So that's something I would probably spend a little bit of time on at this point. And once this sits, we can build any subsequent tracks from the plates track, which means we don't have to do all this frame fudging more than once. So the next one would be building a playblast track. And you can see at this point, there were already a few playblasts on disk, but many shots didn't have one, so I just get an offline track item. The reason I built the playblast tracks is that obviously for animation, it's super important to be able to work in context of the cut. So now animators can use this project to flipbook their stuff into and always check that it's working in the cut. So for, looks like the playblasts are still the super wide original format, so we probably want to change that just like we did before to fit the height. Actually, we haven't even assigned the sequence resolution. Let's just do that real quick. CDL 2K, and the sequence res was 2580 by 1080. And all the other clips should also be scaling themselves, but to fit horizontally. So with play blasts, we are usually looking at undistorted pixels, meaning the lens distortion is not part of it. The cool thing is that that Nuke's lens distortion node is GPU accelerated, which means we can actually benefit from it in Hiero. So if you publish lens distortion data that is compatible with Nuke's lens distortion node in some way, you could build yourself a little batch that automatically applies lens distortion to play blasts in the timeline and therefore reapply lens distortion in real time without any additional processes. So the next step would pretty much be build the comp track and throw, of course, the look back on top that we set up in the first part. So at this point in time, usually there is no comp available because everybody just started working. But now that we've prepared this timeline, we can just save the whole thing. Let me just call it swap cut master. And as comps become available, we can now update our timeline. But the great thing is we also have HieroPlayer. So that means all artists in all departments benefit from this. So they can open HieroPlayer, grab that master timeline that we just built. And in HieroPlayer, they will be opening this in read-only mode. So they can't accidentally move anything around. But the thing is, what they can do is go back to the comp track. What they can do is, as they render and make these clips available, they can just version up and they will actually come online. So to say I'm an artist working on S120, I can just go to the master clip in HieroPlayer, hit Alt up to, just like a Nuke, to version up, and I can see my render in context of the comp. And use the version scanner to compare befores and afters, etc. So that empowers artists to really kind of bring more creative awareness to the project by enabling them to work in context of the cut.
Here at Foundry, we want you to succeed with your pipeline integrations. We're writing new tools and examples so that you can do this. Nuke Timeline Loader is one of those new tools. So what is Nuke Timeline Loader? It's a customizable bridge, providing an example integration between Flow Production Tracking and Nuke's timeline tools, helping facilitate content review. It's compatible with Nuke Studio, Hiero, and HieroPlayer. We're hoping this enhances workflows across the team with the ability to update statuses, review notes, create annotations, import playlists and cuts to the timeline before publishing all of this back to Flow. This tool is built as a customizable Python template and serves as the foundation for creating a bespoke integration that's tailored to your pipeline's needs.
So with the new NTL in Hiero, we can now communicate directly to Shotgun, and we can see all of our projects. Currently, we only have this one in there. And then when you expand this, you'll see all the playlists or cut entities. So at the moment, we only have 2 playlists. This is where all your dailies, playlists, etc. would be living. And expanding this will simply show you the familiar looking Shotgun versions. So you can cycle through here. If you're a supervisor that's on the road or away from the network, you can right-click on the playlist and just download all the media from Shotgun directly to do an ad hoc review on the road. It'll obviously be whatever resolution those QuickTimes afford, but that's still a nice little way to go. Realistically, though, you are likely part of the network with a decent review station, so that means you can just directly link to the rendered image sequences on disk, which would have been recorded in Shotgun in some way, and all of this is configurable in NTL, so that's not locking you into any particular configuration or manifest in Shotgun. So now we have the full resolution timeline, and of course we could load our look track again from before. The OCIO look doesn't match the old offline QuickTimes for many reasons, but it should. So, and it would in this case. So ignore that part. And over to the Notes tab, you'll see as you scrub through the timeline, we get a live updating conversation stream that is relevant to the current version under the playhead. So we can now pop in here, do our reviews with annotations, and say, for example, in this case, we would want some grading mats. We can submit that node, which actually just submits it to the current local cache. We can add annotations to that particular node. We can add multiple if we want, and we can just carry on with our review and keep adding notes. And at the end of the review session, so currently everything that's yellow, the notes in here, the track items in the timeline, that signifies that all those shot grid edits, if you like, the notes and the annotations have not been committed to Shotgun just yet. They've been saved locally. They will persist between sessions. So if you need to quit out of this or Hiero crashes, you won't lose any of that review state. And once you're ready, you can go to publish all these changes to Shotgun. And you'll see a change report very similar to the notes review or review notes app, except in NTL, annotations are actually included in the whole batch concept of a review process, something that the review notes app does not do. And another favorite feature of mine is that you can still edit those notes in the report. So that's where you can fix all your typos. That's specifically great for me. And also copy paste the same feedback comment across similar looking shots and all that sort of stuff. So submitting that to ShotGrid will make the track items in the timeline resume their original color. And that means everything has been submitted to Shotgun now. You'll note that we got tags for free that tell us about the status in Shotgun. That also means that helps us with utilizing the contact sheet at this stage to compare or filter out stuff that we want to look at. And instead of using the manual filtering like we did before, we can flick over into the tag-based loading and say, for example, we only want to look at the stuff that is pending review and have a quick look at those. So that's, again, a great tool to check continuity and consistency in our work. You'll also see that the track items came in with the correct shot name. So we can pretty much continue on with our track building workflow like we did before. For example, if these are all the comps ready to go, we can then use the track building to bring in the plates. And enable ourselves to do difference keys, wipes, whatever makes sense in context of your QC workflow. In this case, we were asking for grading mats. And because all of this is still file system specific, we can just version up and get our version 4, which you can see by that little color chip in the track item and also in the drop down here now includes grading channels. And in my workflow, I like to put another track on top that helps me with QCing those sort of things. So I'll pop over into Nuke for a second and grab some grading nodes and a text node. I'll explain what that is about in a second. And create a new track. I'll call it QC. And just paste my Nuke nodes on top. So you can see that the grading nodes simply grade each respective channel. And in this particular show, we're looking for a layer called grading red, green, and blue with red, green, and blue channels. So that means we can just toggle that track on and make sure we have embedded grading channels for the shots that we expect them for. And then the text node up top is just an example of how you can still use that, for example, to check the data window, because that's been, or that can be a problem for DI if the data window doesn't match the display window. In other words, if the bounding box doesn't match the format, that can be something that DI has to kick back because they can't deal with it very well. So I know Bigger facilities will have delivery pipelines that reset all that and make sure that works. But it's just as an example what else you can do in the QCing process inside of Nuke. And in this case, we just see, let me just turn off those grading nodes. We can see very quickly which bounding box needs attention. So at this point, in my personal workflow at Ohu FX, we would use this sort of string out as well as the previously shown swap cut project to deliver final EXRs along with EDLs to place them in the context of the sequence and or film. And the ability to run EDLs out for delivery is something that the client-side editorial, the online editorial, and the DI guys really love getting. So that just kind of comes for free in this whole workflow. And that's pretty much all I've got to show.
I'd like to do a shout out and a special thanks to Fathom for providing us the Cradle project. And I hope you've enjoyed watching.